talking about Unit 6, and in Unit 6 today we're going to talk about graphing and solutions to inequalities. So let's go ahead and get started with all the information that we have right in front of us. So before we get started, a solution to an inequality is any value that makes that inequality true. So anytime that we're talking about solutions, you need to make sure that it's making the inequality a true statement. And inequalities usually have many solutions. It's not like an equation. In an equation, there's only one answer. X equals 3, the answer is 3. In inequalities, there could be many solutions. And we're going to talk what that looks like today. However, you just need to know going in that you're not going to always have just one answer to an inequality. So let's start there on the left with finding solutions. So the first inequality we have is x is less than 3. If you're not sure whether that sign's less than or greater than, remember way back when you were in elementary school that the alligator eats the bigger sign. So when the alligator or the open mouth is facing the variable, that's going to be greater than. And if the open mouth is not facing the variable, then that's going to be less than. So in this case, we have circle all the solutions to the inequality x is less than 12. So let's fill in that blank. We should circle any number that is less than 12. So now looking at all of our choices, we've got negative 10, 12, 7, 6, 15, 90, 0. So we're going to go through, we're going to circle anything that would be less than. So is negative 10 less than? Yes. Let's skip 12 for a moment. 7 is less than, 6 is less than, 15, nope, 90, nope. 0 is less than 12, yes, those work. Now let's take a look at 12. Is 12 less than 12? No, it's not. 12 is equal to 12. So I cannot include 12 in this particular problem because it doesn't say x is less than or equal to. It just says less than. And since 12 is not less than 12, I don't circle it. So even though you see 12 there and you're tempted, hey, I see 12 in the problem, so it must be 12, that is not a correct answer because it doesn't make the inequality true. 12 is not less than 12. So since that is not a true statement, it is not a solution to an inequality. Now let's talk about graphing our inequality for x is less than 12. So it says graph the inequality is less than 12 there on the right hand side. So a few things before we get started. We're going to use an open circle because our solution will not include 12. Since we can't say that 12 is going to be part of our solution, we're going to be using an open circle. So on our graph, we're going to be putting an open circle, and then we're going to be writing the number 12 because that's our number here. So now we need to figure out which way our arrow is going to point when we're graphing inequalities. Because remember, there's not just one answer. It's not just 12. It's all the numbers that are less than 12. So where are the numbers that are less than 12? Well, in this case, our arrow is going to be pointing to the left because all the numbers that are less than 12 are going to be on the left of the number line. So we're going to be drawing an arrow down to the left to show that all of the numbers to the left of this point are possibilities to make this inequality true. So negative 10 could be there, 5 could be there, 7 could be there. All of those numbers are less than 12. So all of those are solutions. So again, our arrow is going to point to the left because that's where the things that are less than 12 are. Now let's take a look at our second inequality to find a solution for there down at the bottom left-hand side where we're talking about circling all the solutions to the inequality negative 10. Now again, I'm taking a look at my sign, and my sign has the open mouth eating the variable. So since the open mouth or the alligator is eating the variable, I know we have greater than for the variable or less than facing the negative 10. So you can just read it either way. Negative 10 is less than or equal to x, or x is greater than or equal to negative 10. I will highly, highly, highly recommend to you that no matter where the variable is, on the right or the left, whenever you're reading this aloud to yourself or reading it aloud in your head, you always want to start from the variable. So it's very, very important to find that variable and read your statement that way because that's how you're going to find solutions. So x is greater than or equal to negative 10 is the way that I would read this inequality. It doesn't matter whether it's on the right or the left. You always want to read it in your head and out loud from the variable. So knowing now that we're going to be looking at x is greater than or equal to in this case, so we have two things, we should circle any number that is either greater than or equal to negative 10. So again, before we couldn't include the 12 because it didn't say equal to. In this case, it does say equal to, so we can include negative 10 if we come across it. So now let's circle the ones that are going to be solutions. Is 0 going to be greater than negative 10? Yes, I'd rather have $0 than owe somebody $10. Is negative 80 going to be greater than negative 10? No, I'd rather owe somebody $10 than $80. 15, obviously, positive greater than the negative. 10, positive greater than the negative. Now I've got negative 10. And in this case, it says that I can have equal to. So is negative 10 greater than or equal to negative 10? Yes, it is. That's a true statement, so that makes it a solution, so I can go ahead and circle that. Negative 12, no, not greater than negative 10. 3 is. Negative 7 greater than negative 10? Yes, I would rather owe somebody $7 than owe them $10, so that is a solution. Remember, you're looking for things to make the statement true. As we talked about before, inequalities are going to have many solutions. Look at all the solutions we have for that particular problem. So they're going to have lots of solutions for inequalities, and that's something you're going to have to get used to. Now let's take a look at graphing that inequality, and it says graph the inequality negative 10 less than or equal to x, but remember, I'm going to be reading from the variable. So the variable is x. X is greater than or equal to negative 10. Now in this case, we're going to need to make sure that we're going to use a closed circle because our solutions do include negative 10. So I'm going to go ahead and draw myself a closed circle right here in the middle, and we're going to be talking about negative 10, so we want to put negative 10 on our graph. Now we need to figure out which way our arrow points, and since we're going to be talking about numbers that are greater than, all the numbers that are greater than negative 10 are going to be on the right. So our arrow that we need to draw is to the right-hand side. So I'm going to go ahead and do that now. And that indicates that all the numbers past that dot, including that dot on the right-hand side, are solutions to this inequality, or they are statements that will make this inequality true. Now let's go ahead and take a look at a few more examples. Now here in the second part of the notes, we're going to be talking about solving inequalities and their steps to do so. Now the good news about solving inequalities is it's very, very, very similar to solving it like equations. Not exactly, but very similar. So let's go over the few steps that we have. First of all, remember we're always going to draw a wall, and then we're going to be using our inverse operations to solve the inequality just like an equation. But don't forget to include the inequality symbol in your answer. So again, you can't just write 3 as an answer for this particular problem like we could in an equation, because there are many answers. So we always have to have our inequality symbol, we always have to have our variable, and we always have to have whatever our solution is going to be. So let's take a look at number 1. In number 1, I've got 8 plus x is greater than 12. So again, I'm first going to start by drawing my wall. And then I need to remember that I'm going to be using my inverse operations just like I would in equations. So I have a positive 8. The opposite of positive 8, or the inverse of positive 8, is negative 8. So I'm going to subtract 8 on both sides. I'm going to bring down my x, bring down my inequality symbol because that's very important. And then 12 minus 8 is 4. So now I've got the solution, x is greater than 4. So now that I've got that as my solution, I have to go ahead and graph. So I'm going to start by drawing either an open dot or a closed dot. In this case, it doesn't say equal to, so I'm going to be drawing an open dot. So I'm going to be putting that one in the middle. And my number that I've gotten for my answer is 4, so I'm going to write that below. So now I need to figure out if my arrow is going to go to the right or to the left. So I'm going to go back and read my solution. It says x is greater than 4, so I know the numbers that are greater than 4 are going to be on the right-hand side. So I'm going to draw an arrow going to the right-hand side. Then I'm going to circle all my possible solutions. So I'm looking for things that are greater than 4. So is 12 greater than 4? Yes. Is negative 8 greater than 4? No. Is 4 greater than 4? So let's take a look. It doesn't say greater than or equal to, so 4 does not make this inequality true, so it is not a solution. Is 6 greater than 4? Yes. And is 13 greater than 4? Yes. So all of those things were solutions. I made sure that not to circle my 4, and I was able to complete the problem. Now let's take a look here at number 2. In number 2, the first thing I'm going to do is draw my wall down from my inequality symbol. Now I've got x minus 15, so I'm going to be doing my inverse operation. The inverse operation of negative 15 is positive 15, so I'm going to be adding 15 to both sides of my inequality. These are going to cancel, bring down my x, bring down my inequality symbol. Negative 9 plus 15 is going to give me positive 6. Again, if you don't know your integer rules, feel free to use your calculator. You're more than welcome to do that. Now let's take a look at our graph. And again, I'm going to be putting a number in the middle. In this case, it's 6. Now I need to figure out, am I going to be using an open dot or a closed dot? Since I have less than or equal to, I have equal to there. I know I'm going to have a closed dot. Now I need to figure out which way my arrow is going to go. And again, remember, I'm going to be reading from the variable, and the variable may be on the right-hand side, but I'm going to read from that direction. And it says x is less than or equal to 6. So where are the numbers that are less than 6? They're to the left. So I'm going to draw my arrow to the left. And now I need to figure out solutions. So is 6 less than or equal to 6? Well, luckily it says equal to, so it is a solution in this particular case. Is negative 90 less than 6? Yes. Is 13 less than 6? No. Is 1 less than 6? Yes. Is 7 less than 6? No. So those are all the solutions to my inequality. Now we have to look at some fun word problems when we're talking about inequalities. So number 3 there says, last Friday, Kara had $22.50. Over the weekend, she received some money and now has more than $32. That more than is going to be very important. How much money could she have received this weekend? Now we need to write an inequality, and then we have to solve said inequality. So that more than is going to be very important for us because it's going to let us know whether we're going to be dealing with greater than or less than. Since the amount of money that she's going to be having is going to be more than the $32, whatever we write for an inequality, we know that it has to be greater than the amount that she's going to have at the end is going to be greater than the $32. So we know she had $22.50. We're going to add some amount of money to that. We don't know what that is, but we know when we're done with that, we want that to be greater than $32. So here's our inequality, our $22.50, which she had. We're going to add some amount of money to that. We don't know how much because it doesn't tell us. That's what we're going to be figuring out. But we know that we want it to be more than 32. So again, it's going to be greater than. That more than is the key to this entire inequality. If we miss that important key phrase, we wouldn't figure out which way our arrow is supposed to go. So now let's go ahead and solve our inequality. So we're going to do that by drawing a wall down from our inequality symbol. Then we're going to be using our inverse operation. So the opposite of 2250 is going to be negative 2250. So we're going to be doing that on both sides of our inequality. Remember, if you don't know your integer rules, it's okay to use your calculator. Positive 22 and negative 2250 are going to cancel each other out. That's going to make sure that I bring down my x, bring down my inequality symbol. Then 32 minus 2250 is 950. So again, I'm going to put my 9.50. So now I've got my inequality is x is greater than 950. Now remember, we're talking about a word problem, so we need a word answer. So I'm going to make sure that I throw my dollar symbol on top of that 950. So we're not talking about now that x is greater than $9.50. So we're going to go over here and graph it. So in order to graph it, I need to know what I'm writing out. And my answer is going to be 950 as I just figured out. Now I need to figure out whether I'm going to have an open dot or a closed dot, since we're just talking about greater than, because we knew the amount had to be more than $32. It couldn't be exactly $32. It had to be more than $32. So in that case, we're going to be using an open circle because we don't have equal to. Then we need to figure out our arrows going to the right or to the left. And since we're talking about greater than, the numbers that are greater than 950 are on the right-hand side. So that's what I'm going to do by drawing my arrow to the right. Now let's take a look at number 4. Number 4, Keith has money in his checking account. He wants to spend $87. So again, spending is one of our key words on new sports equipment. He must keep at least $25 in the bank account. That at least is going to be our key phrase. How much money must he have at the beginning? So now we've got pieces of our information. We know that spend means to subtract, so we're going to be doing some subtracting. And we need to know we have at least $25. So we know that we have to have at least $25. That means the amount can't be less than $25, but it could be $25. So that indicates to us that we're going to probably have equal to here. So let's set up our inequality. We don't know how much money he starts with, so that's going to be our x. He wants to spend $87, so we know we're going to be subtracting that amount of money. And we know that when we're done with all of that, we want that amount to be greater than or equal to $25 because we want to make sure that we have at least $25 in our bank account. If our inequality was less than 25 or equal to 25, then we know that that would not be true because then we wouldn't have at least $25. So we got 17 as our answer. That's not at least $25. So we need to make sure that we have greater than or equal to as our inequality sign. So now we're going to go ahead and solve. We're going to do that by drawing a line down from our inequality symbol. Then we're going to be using our inverse operation. So the opposite of negative 87 or minus 87, they mean the same thing, is going to be adding 87 or positive 87 either way. Negative 87 and positive 87 are going to cancel each other out. Bring down my x, bring down my inequality symbol, and then 25 plus 87 is 112. So now I've got the answer of x is greater than or equal to 112. So I'm going to make sure that I put that down underneath my graph as the number that we're going to be talking about. Now I need to figure out, do I have an open dot or a closed dot? Since I have equal to, I know I have a closed dot in this scenario. And then I need to figure out which way my arrow is going to be pointing. And since x is greater than or equal to 112, the numbers that are greater to are to the right-hand side. So I'm going to be drawing my arrow to the right. All right, now let's try a couple on your own. Here we are at examples 5 and 6. I want you to try these two on your own. You're going to pause the video now, try them, do the best that you can, then press play again to see if you are right. How did you do? Were you able to come up with the same answers that I came up with? Hopefully you did. If not, some important information that you may have missed: when the bookcase can hold no more than, that means your amount's going to be less than that, because if you start loading the bookcase with more than that, then the bookcase will collapse. Same thing with the penguin temperature. It must stay below 6 degrees, so again, it has to be less than, because if it were to become greater than that temperature, then the penguin would not be doing so well. If you didn't get the answers that I got, go ahead and make sure to fix your paper so it looks like mine. Look through my work where you may have made your mistake. That brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.